This is the first lesson in electricity in GCSE, and it's important to understand the concept of charge before we think more deeply about electrical circuits. Now, charge is a property that all matter has. Now, you've encountered charge before, so if you think about your understanding of an atom, we've obviously got the nucleus in the centre, and we've got the electrons orbiting around the outside. So we have protons, we have neutrons, both in the nucleus, and then we also have electrons. Now, electrons have a charge, and the symbol for charge is Q, equal to -1, and it's -1 E. And just to explain what E is the charge on an electron, which is 1.6 times 10 to the minus 19 coulombs. So this is an incredibly small number, but obviously a single electron only has a very small charge. And we measure charge in the unit coulombs, but I'll come back to that in a second. So in simple terms, we know that electrons have a negative or -1 charge. Protons have a positive charge, +1 E, and neutrons are neutral, which means they have a charge of 0. Now, if we think about the overall atom, and this one that I've drawn here is an example of a helium atom, and we know this because it's got 2 protons and 2 neutrons. And because it's got 2 protons, it also has 2 electrons. So the defining feature of an atom is that atoms have the same number of protons and electrons. Now that is important because what that means is that atoms are uncharged, or they're neutral. So if you think about here, in this atom, we have 2 protons and 2 electrons. Obviously we have 2 neutrons as well, but they don't have a charge. So the 2 positives from the protons will cancel out with the -2 from the electrons, and overall the charge is 0. So atoms are uncharged overall. And in chemistry, you'll have learnt about the idea that if you gain or lose electrons, you will then form an ion, which is a charged particle, and that's because you have different numbers of electrons. Now, it's key to understand that the nucleus can't really change. Only bit that can really change is the electrons. So the electrons are free to be lost or to be gained by an atom, whereas the protons and neutrons will stay in the nucleus. That won't change. Now, if we think about going from an atom to something a bit bigger, like an ordinary, not just an ordinary everyday object. So imagine I just got a very simple block of wood as a very simple example. So if I've got a block of wood, in our everyday experience, we don't see this object as being charged in any way. But of course, it's made up of protons, neutrons, and electrons. It's made up of atoms. But the reason it's not charged is because the number of protons and electrons is the same. And so in our everyday experience, we don't see the effect of charges. And the reason for that is because they usually balance each other out, and they usually cancel. The time we would then see the effect of a charge is when they aren't balanced, when a charge has built up on an object. So our everyday experience sort of tells us that objects are uncharged. However, if we think about something like a balloon, so we have a balloon, and I'm just going to represent charges on this balloon as positives and negatives. Now, the reason I'm showing it in this way is just to show that at the moment we have the same number of positives and negatives on this balloon overall, to put it very simply. Now, if I rub this balloon, for example, if I rub it against my jumper, or I rub it with a cloth, so I'm just going to use a cloth for this, then what will happen is as these two materials rub past each other, we're going to get friction. And the friction will, in very simple terms, quite literally rub off electrons from one material to another. So to begin with, just to give the cloth as well, I've got the same number of positives and negatives on both objects, and so they're both neutral to begin with. However, if I rub them together, the effect that I'm going to have is that some of the electrons from one of these objects will get rubbed off and will get transferred onto the other object. So if I consider like after the event, when I've got my balloon and I've got my cloth, then what it will look like now is I will have an excess of electrons on one object. So here I've got overall more negative charges than I do have positive charges, and on this object I'm just going to be left with a deficiency of electrons. So overall this object now is going to be positive. So this represents a couple of really important ideas. Number one, that we have two types of charge. We have charge which is positive and charge which is negative. We could call them anything. We could call them red and blue. We could call them up and down, but we just happen to call them positive and negative. So there are two types of charges. And the reason we know there are two types of charges is to think about what happens when they come together. So if I've got a positive and negative here, just like if I've got a north and a south on a magnet, the key is the opposites. So if I've got a positive and a negative, they will attract to each other, and then the same charge will repel. So if I've got two positives, there will be a force outwards, so they will repel, and if I've got two negatives, it would be exactly the same thing, that they would repel each other, just like a magnet. So we have this idea of there being two types of charges, and we have this idea that the reason we get an imbalance in charge or a charge build-up is because when we have friction between two materials, electrons can be transferred. And remember, we said that protons couldn't be transferred because they are within the nucleus, so only electrons can be moved. So if you're explaining this theory of static electricity, then that is the most important phrase, the most important thing to understand, that electrons are transferred. And this is why we get this charge imbalance of positive and negative. Now, it does matter what these materials are made out of. So I've used the example of a balloon and a cloth. But the key thing about both of these materials is they have to both be insulators. They couldn't be conductors. I couldn't do this with two pieces of metal. And the reason for that is very simple. In a metal, which consists of an array or a lattice of positive cations, and then electrons spread throughout the metallic lattice that are delocalized, so they're moving around in every direction, like so. The reason that you can't get a positive or negative charge build up on a metal is because the electrons are free to move. This is a conductor, and so charge never builds up, and that's the key. You have to have a build up of charge, and remember, insulators don't allow electric current to flow through them, so you get a build up of charge rather than charge freely moving and never building up. So another key piece of information for static electricity is that you have to have two insulators. So I've used this phrase static electricity a few times now, and to clarify what that means, static electricity is when you have a build-up of charge on an object, and it will stay there, it's static, until such a time you bring a conductor near it. So if I was to do this and change this from a cloth to my jumper now, if I was to build up some charge on my jumper, and then so the charge is built up on me, if I was to then touch somebody else, I might give them an electric shock because the current or the charge would flow through me and discharge. So these are some of the basic ideas about charge. There's one final thing that we've got to make sure that we add to this, which is what's unique about charged objects. So if you imagine that I have a proton, like so, then all charged objects have surrounding them an electric field. Now the electric field is radial, which means that it acts out like in a circle around it. And because this object is positive, we draw the arrows going away from it in our field. So this is an electric field. And all charged objects have an electric field. So this would be the field, what it would look like for a positive charge.